Great. Well, great to see all of you again. Thanks so much for taking the time. Thank you for the nice introduction, Dakin. I want to step up a level from any of the individual companies and tell you about how great the relationship has been with Dakin and the whole team at Prime Movers. We have two new companies that we're going to be partnering on in addition to Idealab. And I want to tell you why I'm so excited about that. One, I want to double the number of billion-dollar companies that we've made. I want the other 7 of them to be together with Prime Movers and all of you. But in addition to that, I have to tell you about what it's been like working with the whole team there. I mentioned this a little bit when I was in Jackson Hole, but it's been magnified even more since then. This company, Carbon Capture, that we're working on, we're trying to take CO2 out of the atmosphere, and it's hard. And there's no investor we could speak to who could come to us with Dakin and Carly, where Carly isn't just doing diligence, but she's actually teaching us things. Like, she's telling us about new technologies. She's aware of the companies that we're talking to. She's aware of the techniques, and it's just incredible. So it's so great to be challenged and to be helped. And then similarly with the Stirling company I'll tell you about, Dakin wanted to do diligence and brought Dan on the call. And we spent a couple hours with our tech team and Dakin and Dan. And Dakin came back, Dan came back after looking at everything that we talked about. And again, this is like 50 years of Stirling research I've been working on. And he identified the 2 things that were the biggest risk items, that were truly the biggest risk items. Like, out of all the things we had, he was able to just hone in on, I'm a little bit concerned about the pressure. I'm a little bit concerned about the heat transfer here. Everything else I feel like you've got a handle on. Are there ways you could address that? And that pushed us to think about that and came up with some solutions. And it's just incredible. Like, again, there's no VC firm I've ever worked with that can actually help us on the technical side like that to make our offering better and challenge us like that. So I'm really, really thrilled, and I'm really, really grateful. And that's happened across the board. It happened at Heliogen, and now it's happening with these other companies too. So that's really great. And then there's even another company we've been talking about that Prime Movers has passed on investing. And it's because Suzanne has been so rigorous in helping us identify and improve the business model. And we've been changing the business model of the company, and we might soon have it improved good enough to actually meet the Prime Mover standards. So they might still invest, but they have passed twice already, but it's been helpful. Even in passing, they've been helpful. So that's I'm really just thrilled about working together in that way. So let me tell you a little bit about a few different companies. Let me share the screen with you now. I have already talked about Heliogen. Can you see the screen with the Heliogen mirrors? Yeah, okay, so I've already talked to you about this in Jackson Hole. I just want to summarize a few things very quickly about what we really have honed in on, what the key innovation is that we have developed, and just give you a slight update on where things are, and then talk about some of the new companies. So really what we're trying to do is, and we have achieved, is make heat from the sun cheaper than the cost of fossil fuels for the first time ever. And the way you have to do that is by concentrating sunlight. The reason why it's so important is electricity is already cheaper than fossil fuels from PV panels, but that is only a small portion of our fossil fuel budget. Electricity is only about 25%. 75% is everything else: transportation, heating, and the biggest part, the biggest carbon emitter, is industrial processes to make steel, cement, and all of our building materials. So I really wanted to focus on this area right here. All the things that are the high temperature, big portion of our global emissions: methane reforming, cement calcining, melting steel, making hydrogen from water. And that really is a big, big part of global emissions that I think we can have a very, very big impact on. And traditionally, I showed this before, this is the way concentrated sunshine normally looks like: huge, huge mirrors pointing to a tower. And effectively, what it's doing is building something pretty much the size of a tennis court, reflecting sunlight to a tower. And because it's the size of a tennis court, there's huge, huge weight and wind loads on that. As light as you try to make it, you have a certain stiffness required. So the thing is pretty heavy and it's large. It's a huge sail. And that means really, really stiff, strong gearboxes to move that are too expensive. So we tried all these iterations over the years to come up with a way around it. And the way we came up with was, what about if you break up that big mirror, 10 meters by 10 meters, into 100 smaller mirrors? Well, the wind loads will go way down, but the actuation cost will go way up, because now you have to move 100 things instead of only one thing. But the wind loads go down enough, they go down to the 1.65 power of area. So the wind loads actually go down when you make things smaller, such that you can use more delicate gearboxes, even plastic gearboxes, to move things. And it led to a field like this. This is a picture of the field that we built. And effectively, what we've done is eliminated this big crane, which is required to build this. And now 2 people can just walk around and place out these mirrors in the field. This is what it looks like from above. This is what it looks like with the camera software that is actually looking at all the mirrors and moving them in real time to do that very precise actuation. Because the actuation problem has gone up so much, when you break a big mirror into 100 smaller mirrors, you now have to come up with a new way of actuating. And the way we did it is with closed loop system, using computer vision, looking at each mirror and adjusting them until the reflection of light in the mirror is just right. This is what it looks like when the mirrors are not pointing properly. This is what it looks like when the mirrors just start pointing properly. And then you can see the cameras are always looking to make just the right light intensity in every mirror to make them exactly pointing to the center of the tower. And by doing that, we have what's called no spillage, meaning all the light goes where we want it. Nothing is missing it. And you can see all the light is going into our little tiny 18-inch shoot. To contrast that, in this picture here, you can see lots of spillage. These are rays of light going. Many of them are hitting the tower, but about 33% are missing the tower. You can see some of these beams are going over here. There's a bright spot over there. There's some light over here. That's just because they can't control accurately enough that huge tennis court of a mirror that they're trying to move. So they get a majority of the beams on the tower, but they're missing so much that's lost energy. And we have no lost energy because 100% of the light goes into a little 18-inch diameter circle. So the real breakthrough was we can use less materials and use more software, use less labor because we don't need cranes, and we have no calibration because we're continuously calibrating. Normally, to build that field, is about a 9-month process of calibration to go to every single one of those and survey them accurately and make them precise enough. And you have to do that every once in a while. We don't do that ever because we're doing it always. We're doing it 30 times a second from those cameras. And the net result is, and this is what the real breakthrough is, we can deliver heat for less than 1 cent a kilowatt hour. So nothing, never in history has any energy been made for less than 1 cent a kilowatt hour. Not nuclear, not burning fossil fuels, nothing. And we can make it cleanly for less than 1 cent a kilowatt hour. Our cost target is actually half a cent a kilowatt hour. So we can make it for half a cent a kilowatt hour, sell it for 1 cent a kilowatt hour, and make 50% margin. And that's what we're doing right now. We're talking to customers about 1 cent a kilowatt hour, and they're very excited. It opens up all these different markets for us, selling steam, hydrogen production, steel and glass production. We have many, many people contacting us. From over 1,000 people contacted us. We took the best 100 leads, and we're talking to those right now. But they include, even now, Rio Tinto, Heidelberg Cement, companies in Australia doing mining, many, many exciting applications. And we're looking to close our first POs this month and then begin construction. And then even from the event in Jackson Hole, Dakin introduced me to a large company in Oman, one of the LPs, and they want to build a 30 megawatt facility, just for starters, a 30 megawatt electric facility using our high temperature heat. And that would be a $150 million project. So it's a greenfield project. It might take 2 years to happen, but even that one project alone, that $150 million project, would instantly make the company profitable. Burn rate of the company is relatively low. So 1 or 2 projects, and we're a wildly profitable company, and 100 projects make it fantastic. The capabilities, once we have splitting of water at high temperature, is we have hydrogen, which then we can make fuel as well. Right now, we're displacing fuel. We're not making fuel. Our first projects are to displace fuel by using the high temperature heat to save them fuel. But long term, we want to make fuel. And that's a $1 trillion opportunity to make fuel with the hydrogen we make from splitting water. And these are some of the first customers we're talking to: the Searles Valley Minerals, the Barilla Pasta Company, Cemex, but now we've added a bunch of them to there, the Heidelberg and the Rio Tinto. Rio Tinto has an operation just outside of Nevada. So great desert location, great sunshine, not too far from our office, only 3.5-hour drive from our office. And we have other projects in California. Of course, we want to do Australia, Oman, and other places, but we're going to do the first business in California, probably get profitable on that quickly. One question you might have is, what about the drop in oil prices? It's actually very good for us. Believe it or not, many of the fracking companies that had underwater economics are fully underwater, and they're going out of business. And the price of natural gas is actually going up, even though oil is going down. We don't compete with oil because none of these places that we work with burn oil. They all burn natural gas or other fossil fuel. The other thing is, it all comes down to project IRR. And right now, there's almost no money to be made in oil anymore. The project IRRs are either 0%, 1%, or negative. And our project IRRs are between 10%, 20%, and 33%. So in competition for capital, we're going to be able to really win against even low-priced oil because it's just not economic to do new projects. And I'm writing an op-ed right now. I don't know if I'll be able to get it published in the New York Times or Wall Street Journal, whatever, but I'll try. And an op-ed that, ironically, maybe it took a pandemic for us to solve climate change. Not for the reasons you think, because we don't plan ahead. Like we didn't plan ahead for COVID. We certainly aren't planning ahead for climate change. But COVID is like a reset to the fossil fuel industry. So the fossil fuel industry had a 100-year lead on renewables by getting way out ahead of starting gate. Even though now renewables are cheaper and more economical and have a higher IRR, people were set in their ways investing in that area just because it's been around for 100 years and the business is so big. This new reset almost brings everybody back to a new starting line. And with this fresh starting line, as new projects happen, I think we will win. Well, I know we will win if it's competitive. So we just have to get awareness, but the awareness has been great. Obviously, we've been recognized very well ever since the financing, but also recognized very well by Fast Company recently and others. So we have plenty of awareness and leads. And as we come out of COVID, I really feel we're going to come out even stronger despite that. So that's a quick catch up to date on Heliogen. The next company that we'll be working on together is carbon capture. And I mentioned it briefly in Jackson Hole. We've made a lot of progress on it since then. What carbon capture is doing is moving the atmosphere through a filter and capturing the CO2. And there are many people around the world working on that. It's very challenging. It's very challenging because even though we have a lot of CO2 in the atmosphere, it's only 418 parts per million. 418 parts per million, by the way, up from 415 even just 6 months ago. But it's 418 parts per million. Amazingly, despite almost the whole world shutting down, carbon emissions went down, but only by 6.6%. Like, it's amazing that it only went down by 6.6%. It feels like we shut down to 80%. So I was trying to figure out why did it go down only so little in the first quarter? And the reason is aviation went down by 95%, but aviation is only 3% of carbon emissions. So 0.95 times 3%, that's about 2.5%. Automotive transportation went down, but not completely, because some of the worst emitters, trucks, ships, others, train, are still moving goods around, and they're still emitting a lot. So yes, we stopped driving, but that only affected things a small amount. Electricity would have gone way down, but we just moved our electricity use from the office to our house. So basically, electricity is almost the same. So amazingly, that didn't make that much less emissions. And in materials, cement making, steel making, those companies mostly are still running 24/7, producing the same amount of emissions. Maybe over time, as demand for construction goes down, if it does, but right now construction is continuing almost full speed ahead from funds that had already been allocated. So emissions really have only gone down very little. But back to CO2, 418 parts per million in the atmosphere. That's very low percentage, 0.04%. So you need to move a lot of air and filter out a little bit of stuff. And you need to do that for very low cost. The biggest cost is energy. It's the energy to both move the air, that's one component of it, but then it's the energy to separate the CO2 from the sponge, from the filter. Whatever you pass the air over that the CO2 is going to stick to, it then takes thermal energy to get that CO2 off of it and then to go store it, to go put that away. Well, because of Heliogen, we have a very low-cost way of making that heat energy, making that thermal energy needed to separate the CO2 from the material that you stick it to. In addition, we have a novel method that not only captures the CO2, but captures the water in the atmosphere. And there's almost as much as 10 or 100 times as much water in the atmosphere as there is CO2. Think about 10% humidity, 20% humidity. Even on a dry day, there's way, way more water in the air than there is CO2. That normally has been a problem for CO2 capture. We've turned it into an advantage by actually capturing that water and selling that water as well, because we can produce that water in the desert. We can produce that water where there is no water. And water is going to become increasingly scarce with droughts over time, already is. And therefore, we have two revenue streams. The revenue stream right now from governments and companies who want to pay to remove CO2, but that's not very much. Long-term, the revenue stream from CO2 will be to turn it back into fuel. But short-term, we have a unique value proposition compared to all the other CO2 capture companies in that we produce water, which is sellable immediately on the market and very valuable. So that's the unique angle that we're taking with carbon capture. I'll tell you a little bit more about the exact way we do it. We have this orthogonal approach compared to everybody else that's using low-cost materials, low-cost thermal energy, a very low maintenance system, and it's low temperature inorganic chemistry. Some other people are using high temperature inorganic chemistry. Some other people are using high temperature organic chemistry, but no one's using this combination. And it's because of the water and the low temperature heat that we're able to do it. Our system diagram looks something like this, where we move the air through places where the water is absorbed and then the CO2 is absorbed. And then we move through a variety of systems that we're designing to both recuperate the heat, separate the moisture, separate the CO2. These are some of the engineering studies we've done for this. And this is an example of, these are the things that we shared with Dakin and Carly, and they gave us critical feedback on companies who make these devices, like even this company right here who makes this recuperator for us. Carly is familiar with that company, talking to the executives of that company, introducing us to other companies that make competitive products. All extremely, extremely helpful. Where we are with the company right now is we made a bench test system inside of Idealab where we can take the indoor air of Idealab, and the indoor air of Idealab has about 500 parts per million of CO2, a little bit higher than outdoors because people breathing inside and so on. We take that indoor air, we move it through our system, we measure the water content, we measure the CO2 content, we do the heating, we measure the energy required, and we built the entire flow diagram that we would achieve in a full-scale system on miniature scale slowly on a benchtop. That confirmed all of our parameters that made us believe this will work. Now we have to scale it up. So we're looking to raise, say, $2 to $4, $5 million to do that. And Dakin is leading that round to enable us to do that. And now we'll be able to build a pilot to go do this at full scale. But this came after an extensive amount of diligence and improving the design together as we talk through how to do it. And what this leads to is the competition is taking out CO2 in the $200 to $315 range. Actually, some people are closer to 1,000 right now at small scale, but we believe they can get down into this range. Our system at small scale, we believe, can be about half that. At medium and large scale, we can get below $100, and we're working on some R&D ideas to get that even down below $50. And once we get down to this kind of range, it becomes really economical to do it at large scale. But at all of these scales, for us, we're also taking out water, and that's allowing us to make even more money than the value of the CO2. And a long-term dream is to effectively turn desert into forest, basically because 1 acre of our system is simulative or equal in effect of 100 acres of trees. So effectively, we're building like a technology forest, a forest that does what a forest does, but it does it much faster and much smaller. And because it can use desert land, which doesn't have any water, compared to forest land, which requires water, we can actually put this in a place where nothing else grows. So we could take a corner of the desert here and actually take CO2 out at large scale. And this is using the technology of 1 acre of land takes out 1 ton of CO2 per day. A 390-mile square of land would take out all of Earth's 38 gigatons of emissions. All of Earth, everything that mankind does, emits 38 gigatons. And if we could make something of this size, that would negate all of that. So that would be a huge, huge impact. Now, this is a huge, huge project, and this will cost billions, if not trillions of dollars. But if it's profitable, it will happen. And therefore, that could be a profitable way to potentially really make an impact on reducing climate change and reducing emissions. And basically, what I really feel is the ways that we could really make an impact on the planet's change that we're causing is to alter our lifestyles or to invent technology. And I don't think that humanity is going to alter its lifestyle enough. People love their lifestyle. Like everybody loves their travel, their transportation, their air conditioning, their computers, all of the comfort and conveniences that we have developed with technology, we love them. I just feel that if we can come up with technology to negate that, to negate the bad parts of that, then we can continue to enjoy those. So I'm betting on technology to win. You know, technology got us into this situation over the last 100 years since the Industrial Revolution. I believe technology can get us out, and we just have to do it faster than 100 years. We have to do it in 10 years. Technology will get us out in 100 years, I think, for sure. It's just a matter of there'll be wars if we wait that long. So I feel like doing it faster with technology is not only great for this for the planet, but really, really great for the economic returns, because the economic returns here are just unbelievable. So very excited about that. And this company will be working with Heliogen. So this company is not going to reinvent how to do the heat part. It's inventing the CO2 and water capture process, but it will be buying from Heliogen the solar field that makes the low-cost heat, basically the 1 cent a kilowatt hour heat that Heliogen's offering to other customers. So then there's yet a third company that I'm very excited about that is at even earlier stage, a brand new ground floor company that we're working with Private Movers Lab on as well. And that's a company called Stirling Cycles. And the Stirling engine is an engine that was invented in 1816 by a guy named Robert Stirling in England. It was around the time of James Watt and others. It was a really, really incredible invention. And it was making some progress in competing with the steam engine, but then the internal combustion engine was invented. And the internal combustion engine just completely took over. And the internal combustion engine took over because it has very, very high power density, meaning you can make a very small engine have a lot of power, which was very important for automotive transportation. It was very, very important to have a motor on the back of a Mercedes. You know, Mercedes was making those first gasoline-powered cars. To have an engine that was small enough that would still have 5, 10, 20, 50 horsepower. And the internal combustion engine had that power density. It had all these other negative problems, terrible pollution, terrible maintenance, complexity, but it had really, really great power density. So over 100 years, people spent refining and building the internal combustion engine at scale. Hundreds of billions of internal combustion engines were built, you know, all the way ranging from lawnmowers all the way to automobiles and trucks. And the internal combustion engine won because billions and billions of dollars were put against making factories to make them at scale. And there's a really great TV show, How It's Made, that takes all different kinds of things and shows how they're made, you know, how they make pencils, how they make umbrellas, how they make car engines. And the How It's Made episode on how they make car engines, I really recommend. It's an incredible show I watched with my son. Why it's incredible is you look at a factory that's making internal combustion engines. It's making a 750 horsepower internal combustion engine for like $750. But it's doing it at a factory cost of $5 billion. And the automation in that factory is just insane. Like it's 10 years of just building the factory to make that. But why is that all worth it? Well, because then they're going to make 250,000 Ford pickup trucks a year out of that engine, so they can afford to, and they're going to do that for the next 20 years, so they can afford to do that. Well, the Stirling engine has never had that mass production alongside of it to help it compete with the internal combustion engine. And that has made it never succeed to large scale. But what are the benefits of the Stirling engine? The Stirling engine has no combustion. It can just run on heat. So you don't have to have a fuel that explodes to make it run. You can use heat from the sun, you can use waste heat, you can use all kinds of other heat sources to make it run. Also, unlike the internal combustion engine, it's reversible. So what that means is, instead of just making heat when you run the engine and making mechanical motion, you can do the opposite. You can run it backwards and it makes cold. So it's a heat pump. And it's the most efficient heat pump there is. So if only we could make a Stirling engine at huge, huge scale which we're never going to get the $5 billion and the time to build the factory to make Stirling engines the way internal combustion, and 100 years of evolution of the design. If only you could, though, then it could compete, and it really could make a big difference in a clean energy world. It could really, really have an impact on cooling. It could have a big impact on energy storage. It could have a big impact on waste heat recovery. You could do many things with it. Well, we came up with a new idea for a way to make a Stirling engine that pretty much has no moving parts, that just has liquid moving back and forth inside of it. Therefore, it eliminates all the precision machining and manufacturing required of typical engines. All the machining of the valves and the cylinders and the pistons and the bearings and all of that all go away in this very novel liquid piston engine design. The liquid is sloshing back and forth, transferring the working fluid, which is compressed air, back and forth, moving through liquid-filled heat exchangers. So there's no seals, there's no pistons, and all the engine is this kind of U-shaped, double U-shaped system with heat exchangers inside, and it's just a sealed pipe pressure vessel. It's really, really exciting. It could be so revolutionary that it will not change automotive transportation, but it would change all stationary engines. So engines that are on air conditioners, engines that are on power plants, engines in all kinds of other locations that are stationary. Because it still has the weakness of not as good power density as a automotive engine, as a internal combustion engine, but it has the huge benefit of being almost double the efficiency, and finally, it could be lower cost without having to build a $5 billion factory, maybe building a $1 million factory. So we built a prototype of this out of PVC pipe and simple aluminum tubes for heat exchangers, and it seems to work according to the theory prediction. We modeled this in ANSYS and FlowWorks, and we modeled this with some CFD simulations to prove the concept. It worked on paper, it worked on computer, and then we built a physical model just with PVC pipe and heat exchangers to confirm the pressure swings and all that, and all of that worked. Then we shared that with Dakin and Dan, and we went through all the risks and all the challenges. And like I said, Dan came back with two very thoughtful things, the two most critical points. If there were a way to reduce those risks, maybe it would be appropriate to go forward right away. We came up with a way of doing that to address those two things, and then we just decided to go forward with a small investment. This is a $250,000 investment at a $2 million valuation. So it's a very early stage to go ahead and now put a team together and take this forward. So in all three of these companies I just mentioned, Stirling Engine is the earliest. It's just beyond a science project because we've done a lot more work than just a napkin sketch, but it really is a science project. But I hope it can be a huge, huge impactful company that can really change things in powerful ways. Carbon capture, which is further along, we've built a proof of concept in the lab, and now we're about to scale it up to a full-size thing. And Heliogen, which is way past that. We've already built the full-size thing, and now we're going out to customers. So 3 companies, all making a big positive impact on climate change, 3 different stages, all working side by side with prime movers. We're very, very excited to be collaborating on those. And then very, very quickly, right now in the Idealab studio portfolio, we have 12 companies. These are the 12 companies in our portfolio right now, including Heliogen, including carbon capture, other companies that we've started. These are my 12 current thinking about ideas for the next companies we would start. One of them just got formed, Stirling Cycles. We just are forming that right now based on Dakin's commitment. What I'm always doing, and I can describe to you how the process works at Idealab Studio, is I'm always having, our last 50 or 100 ideas that we'd like, and I'm always working to get my handful of sort of top 10, in this case, my top 12. My top 12 ideas that I'm noodling right now for the next companies to start. What does it take for us to start one of them? Well, we have to find a great founder, a great CEO to lead the effort. We have to prove the technology out a little bit further. So we really, before we take money from anybody else outside of Idealab Studio, we want to make sure there's some proof, just like we did with the Stirling case. And then we need to make sure the timing is right. Like, is the world really ready for this? Like I have one idea here, for example. This idea, GeoBargains, is an idea I've had for a while. We have investors lined up for it. People are dying to put money in this. I don't quite have a CEO for it yet, but right now the timing is really bad. This is a retail-oriented bargain site, and retail is in the toilet right now because of COVID. So we wouldn't start that company right now. But when retail springs back, if we find the right CEO, maybe we would start that company. Other companies here, robots for cooking, people bar for communications, e-business for building distributed corporations, all these different ideas are things that we're thinking about. And then as we find a great CEO and as we find a great investor, we will form that company. And then what we're doing now with Dakin is Dakin's making a small investment in Idealab Studio directly, and we're going to bring all these ideas to Dakin first. Like right as we go for the first outside funding, we want to really give a great look in case it's a good fit with the prime movers charter, then it's a good fit. Some companies we start won't be, some companies we start will be, but we'll get feedback. It's not ready for us yet. We want to have that open discussion, but so far prime movers has been so helpful to us. We really want to have that relationship even more tight than it has been, although I can't imagine it getting any better than it is. We really want to try and make that a great way for us to collaborate more tightly on new companies that we start. Personally, I think, you know, my main focus is really on climate change. So the Stirling company, the carbon capture company, Heliogen, and our other energy storage company, Energy Vault, are really what my prime focus is. Energy Vault is another company that now, through its holdings in Idealab Studio, now all of you will be indirect owners in Energy Vault as well, which is our fourth company in the energy space, which is really, really exciting opportunity to really make a difference for electricity. So that's about electricity storage, whereas the company at Heliogen, we're talking about the high temperature heat. So that gives you a quick update on the three things we're working on, the fourth being Idealab Studio, and the new ideas I'm thinking about. I'd love to keep all of you informed about the new ideas that I'm thinking about too, because you might know great CEOs that we can find, or you might say, oh, I love that idea, that would be good. You might tell me, you know, as we were talking earlier, hey, Brazil, this would work really well in Brazil, or oh, this would be really great in this area. There might be things that about market that I don't know about that you could be helpful with. So hopefully as we make this relationship even tighter with prime movers, we'll keep you up to date on all the new things I'm thinking about. And boy, if you could help us with talent, that would be incredible. But Dakin is already doing that. So you should know that, rest assured that there's already a representative working on all of your behalf to make sure that we get that for these companies, which is really, really great. And with that, thank you very much. You've been a great audience, and I want to open it up to questions because I love telling you about all of that.
Well, thank you, Bill. We can give you a round of applause.
Oh, thanks. Thanks. Oh yeah, I have the participant window open on the side, so if you click on the raise hand button, I can see if you want to ask, or just feel free to talk.
Because it's a Zoom meeting, people can just speak up.
Yeah, just speak up.
Two other things before people do that.
Yeah.
One, thank you, Bill. I had no idea you were going to say all those kind of things. I thought you were just going to make a presentation. You're way too nice. And then just to clarify a few things for people. So because we hadn't sent an email out about this yet, like Bill and I agreed on like the final terms on these things yesterday. For people's context, we're putting in $2.5 million as part of a $5 million round for carbon capture on a $15 million pre-money valuation. We're putting in $250K to Stirling as part of a $500K financing on a $2 million pre-money valuation. That one's obviously earlier than we would generally do. The way I think about it from all of our perspective is we may lose $250,000 here. It's like super early stage, but if it's right, we're going to be there with a big chunk of this company, and it's going to be a very big company. And then we're putting in $500K to Idealab Studio itself, which is a combination of those 12 companies plus all future companies that Bill builds. And from our perspective as investors working on breakthrough scientific inventions, I think the main thing that's really interesting for us about that, it's obviously exciting financially, is we also are getting a right to put in $500K to any Idealab Studio companies that come forward in the future. So kind of further cementing that partnership. So that's in a nutshell. What questions do people have? I'm sure there's a lot.
Thanks, Dakin.
I'm sure Zia has a question. Zia, we can't hear you.
Sorry, Bill.
Yes.
Thank you very much. And I've got my daughter here who wants to participate in the video, so I let her.
Oh, great. Awesome.
But Bill, can you take us through what you, in terms of the commercial side of Heliogen, take us through a little bit. I mean, the scale of this company can be just so immense. It's
Oh, yeah.
unfathomable sometimes.
Yeah.
But take us through what are the stages you envision going through in the next 12, 24 months that are kind of hallmarks with which we can think about how this entity gets commercialized. One question. Second question is, what's the method you're going to use? Are you really going to use a project-based method? Meaning, let's say you've got the Oman entity and you become a stakeholder, meaning a percentage owner, or is that a fee income generation kind of model? What is that you're thinking about?
Yeah. Well, let me address both of them. So first, on what are the stages? So many of the customers that we're talking to need approximately a gigawatt of heat. So 1 billion watts. So huge, huge project. So no one's going to start with a gigawatt right out of the gate. I think that we'll probably do something like 10 megawatts for them at first for about $10 million. And maybe we could do that, end of this year, beginning of next year. Then they'll do 50 megawatts the year after, then they'll do the whole gigawatt. Now, some people maybe, and that gigawatt be about $1 billion. So the progression with the customer will be something like, 1/100th of their size of their project to start, 10 out of 1,000, and then maybe 1/10, and then the whole thing. So maybe two steps of factors of 10 to get to the full size they need. And since we can't finance $1 billion ourselves, there will be a separate project. Now to your separate question. So we raised $25 million. We want to get profitable on that $25 million. Ideally, we would have no additional dilution, or if we have any more dilution, it'll be at a much higher valuation, or it'd be in an IPO or something like that. So with $25 million, we can't finance the project entirely ourselves. What we can do is take a small equity stake in the project, but get other financial partners who will own the project. Maybe we get some carried interest royalty on the project, but the majority of it is going to be owned by other partners. But we'll get the cash up front to pay for the project. So let's say that $150 million project in Oman. Let's take that one as an example. Dakin has introduced us to Dallas from Gulf Capital, and Gulf Capital maybe would be the financier of that project. So what we have to show Gulf Capital is that by spending $150 million, they can make a 15% unlevered IRR. Then they'll go forward with it. And then maybe we would do a project where we take 5% equity, they take 95% equity, or they get a bank to finance part of it too, giving them an even higher IRR, but now with some leverage. And but we'll get our $150 million. Hopefully we'll produce it for $75 million, so we can make 2 to 1, make a $75 million profit on a sale like that. And then they'll get their earnings over time as the plant produces electricity. So we will probably have separate LLCs for each of the projects. And maybe what we will do is, once we show 1 or 2 projects and how good the returns are, maybe we would raise a separate project finance fund just to fund these projects, so that Heliogen would get some carried interest for doing that. But that's down the road. That wouldn't be for a year or two. Because right now, we don't have a track record to raise that fund, but in a year or two, we probably would.
And I've discussed with some of you guys the idea of actually putting together a Prime Movers Lab project finance vehicle that would do some Heliogen projects and some e-works projects. And most of our companies actually are well suited for this. So something to keep an eye out for.
As soon as I show, lockdown with say 6 months of operation, returns for the project, then I would be able to come back to you and say, look, I think it's going to be no brainer to do project finance of more of these, and I'd rather go to you than to a bank. And so we'll have that hopefully in a year or two.
I've got a question.
Yep.
Hi, Bill. It's Scott Gibson.
Hi.
So
Hi.
here's something like sustainable hydrogen, if that might go more at the scaling that you're going because of the science and the finance, meaning they can only put so much pure hydrogen in to replace natural gas in a blend for a lot of reasons.
Yep.
So could that be something? Are you working with anyone, Air Liquide or anyone like that, to create projects that would meet your scale up more efficiently?
Yes. So Air Liquide is one, and Air Products is another. I think we've been talking to the CEO of both those companies,
Great.
And they're very interested. What you're referring to is how they can mix in, something like between 3 and 5% hydrogen into the existing gas pipelines, and
Yes.
that's about as much as they can do. But that's still huge, obviously. Like the amount of volume of gas that goes through just the one pipe that goes across California into LA is enormous. And if we took 3% of that, that's billions of dollars. And Southern California Gas wants to do that too. Interestingly, Southern California Electric, Southern California Edison, they are going renewable because they can make solar fields and wind farms. Southern California Gas has no way to go renewable, and they're being pushed. We can help them. So they really, really want something like some green hydrogen that they can add to their pipelines to definitely make a difference. But the market for hydrogen is way beyond the 3 to 5% we can put in the pipeline. We can make pure hydrogen and convert that to other liquid fuels, and then that market is unlimited. And then we're not. Hydrogen is incredible for its cleanness and its energy density, but it's awful for its transportation problem because it's so light and volumetrically it's so bad. But once you turn hydrogen into a liquid fuel, then it's fantastic. So hydrogen plus, okay, so the long-term dream, and you see how these all come together, we take CO2 out of the atmosphere. We crack the CO2 into C, or CO, and we crack the water we took out of the atmosphere into hydrogen. Now we combine the hydrogen and the C, and we make liquid fuels. And we did all of it from the atmosphere. So that's almost like completing the cycle of we emit pollution from our tailpipes into the atmosphere, then we pull it back out and turn it back into fuel again. If we can do that economically, that's the ultimate perpetual cycle. And that's really the goal for both those companies together.
Great, thanks.
Quick question on Heliogen. Have you given a thought to the existing industrial capacity that is in geographies that would be well suited for this? Obviously you could do greenfield factories, but
right.
as an add-on to.
Well, that's a great question. It's only about half, but it's half. Meaning when we talk to Cemex or Heidelberg or some of the other companies, and they say, which of your locations would this be amenable to? And they look at them, half of them are in really, really good sunshine areas with lots of land around them, and half of them are not. So right away, we would just write off those half. That's still unbelievable, way bigger opportunity that we can handle. But then, of course, as you said, it's 100% a greenfield. So we have a steel company from Italy that came to us, and they want to build greenfield in California. Why? Why would they build a greenfield plant in California? Well, if you build a greenfield steel plant in California and you make it zero emissions, you pretty much can own the California market, because if you can make a low transportation cost, but be allowed to make it here, like you can't build a steel plant in California if it's going to have the emissions. So there are no steel plants in California, but they want to come build a fully renewable steel plant in California. They'll invest billions of dollars to do that because they'll just own the market. So there are a lot of companies that want to go do greenfield systems that take advantage of the sun and take advantage of local laws, regulations and benefits. So that one we're very excited about. That one we didn't even know about that opportunity. They came to us just because when we announced the company, they read about it and said, this is unbelievable. We need to change our charter of our company to go build greenfield plants using this technology. That was very exciting.
And similar greenfield or similar geographic question, are there some places where carbon capture just makes more sense because of a variety of reasons or higher carbon density?
Oh, it doesn't. The carbon density is very close. Like I think if we're at 418 ppm right now, that's plus or minus 2 all over the world. So that's the same. But it does make a big difference on carbon capture where you are from the other environmental aspects. So our particular carbon capture is favorable to having moisture in the atmosphere, but it also can be relatively dry. We don't care because even a desert is 10% humidity, and that's good enough. 30% humidity is fantastic. Those are all fine. And higher is okay as well. But we need a lot of sunshine. So we have to go to the deserts because our thing runs on the heat. Some of the other carbon capture methods, they need high humidity, like they need 80% humidity. They can't go to the desert, and they don't work on sunshine. They burn fossil fuels. So desert is not good for them. So Carbon Engineering, one of our competitors, they're up in Vancouver because they need cheap electricity from hydropower. They burn natural gas and they capture the emissions from that. and they sort of double count that in their carbon capture numbers, which is kind of weird. But they need the high humidity, so they can't go to the desert. So I think they're always going to be challenged, because if they don't have a lot of water in the air, their system doesn't work. Whereas we don't need water in the air. We take the water out, but we don't need a lot of water in the air to make our system work. So, but yes, every carbon capture method has its unique geographical requirements. I'd like to think we have the best ones, because all we need is dead land, that is the cheapest land possible, and we just need sunshine. Great, these are great questions. Thank you so much.
Bill, I had a question kind of on that same thing. When you showed that picture earlier about putting all of your capacity in one place,
Yeah.
is that going to be able to reach all of the
Oh yeah,
carbon emissions everywhere? Because I think that it would use it all up, and then
that's a great question. We wouldn't put it all in one place, just because I don't think you would do it like that. You'd spread it around the deserts, but it actually would work if you put it all in one place. Because what happens is all the air is circulating around the earth, and it would even out. Like if you pull CO2 out of one place, CO2 goes in to fill that in. You know, it's like if you're emptying a pool, you know, next to a empty land, it just spills over. So it would even out. You actually could put it all in one place, but in reality, we would spread it, and there'd be, you know, 10 square miles in this desert, 10 square miles in that desert, you know, spread out in different locations. But amazingly, the CO2 does even out, sort of just like the oxygen evens out. Like if you were taking oxygen out right here in my backyard, it would just fill in from somewhere else. So it all evens out pretty fast. Faster than we can take it out, it would even out.
Does anyone else have questions?
Great. Well, it's really great to speak to all of you. I'm really thrilled to be a part of your group. Honored to be a part of your group. I'm complimentary to all of you for choosing Dakin and the Prime Movers team, because I think you've picked someone great, and I'm just thrilled to be part of this. It's really, really great. When I find someone this good, I want to keep working with them over and over again. And you've seen that happen even just since we met in Jackson Hole. And I'm sure there'll be a lot more to come.
Well, thank you, Bill. I think the honor is all of ours for what you're doing for the world, and that we get to play a small part.
Yeah, big part.